Slide 1, start. Mysterious electronic hum fades in the quantum realm. Something extraordinary happens when we're not looking. A particle passes through two slits simultaneously, creating an interference pattern that shouldn't be possible. But the moment we try to observe which path it took, reality itself seems to change. Welcome to the philosophical implications of science, where the very fabric of our reality unravels before our eyes. What if I told you that everything you think you know about reality might be wrong? That the chair you're sitting on is mostly empty space? That time itself might be an illusion. These aren't just philosophical musings. They're implications drawn from our most rigorous scientific theories. The story begins with quantum mechanics, perhaps the most successful scientific theory ever devised. Yet its implications are so profound that even Einstein struggled to accept them. When we observe quantum systems, we don't just measure them, we fundamentally change them. Consider this. If consciousness affects quantum measurements, what role does consciousness play in creating reality? Some philosophers and physicists suggest that consciousness might be fundamental to the universe itself, not just an emergent property of complex brains. Transition to simulation visualization, but perhaps an even more unsettling possibility lurks in the mathematics of our universe. What if our entire reality is a simulation? The computational nature of physical laws has led some scientists to propose that we might be living in an advanced computer simulation. Let's delve deeper into the question of free will. Modern neuroscience shows that our brains make decisions before we're consciously aware of them. Yet quantum mechanics suggests fundamental indeterminacy in the universe. Are we truly free, or are we elaborate biological machines following the laws of physics? The answer might lie in the strange quantum realm, where probability clouds replace certainty. Dramatic pause, but perhaps the most profound implication comes from mathematics itself. Gödel's incompleteness theorems show that in any consistent mathematical system complex enough to describe arithmetic, there are true statements that cannot be proven within that system. What does this mean for science? Are there fundamental limits to what we can know? Heisenberg's uncertainty principle suggests yes, there are pairs of properties that cannot be simultaneously known with perfect precision. This leads us to a startling conclusion. Perfect knowledge might be impossible not because of our limitations, but because of the fundamental nature of reality itself. The ethical implications are equally profound. As science gives us unprecedented power to manipulate nature, from CRISPR gene editing to artificial intelligence, we face questions that science alone cannot answer. Can science tell us what we ought to do? The Azot problem, first identified by philosopher David Hume, suggests that we cannot derive ethical statements purely from factual ones. Yet as science advances, these philosophical questions become increasingly urgent. The development of artificial intelligence raises questions about consciousness and moral responsibility. Music swells, we stand at a unique moment in human history, where our scientific knowledge forces us to confront the deepest questions about existence, consciousness, and reality itself. Music fades to contemplative tone as we close. Remember that these questions aren't just academic exercises. They challenge our fundamental understanding of ourselves and our place in the cosmos. Keep questioning, keep wondering, and keep exploring the profound implications of our scientific discoveries.